All right, let's wrap this up by doing some problems that puts everything all together. So we have our sine and cosine functions here, and we have all the pieces that could be doing stuff. So we have our amplitude change, we have something that would change the period, and then we have our phase shift. Now it's important that it's in this form. Notice how the b is factored out of the x minus c. So if you see something that is not of this form, you have to factor out that number. And one of the examples we do is going to require us to do that. And so the amplitude is just always, we just talk about the absolute value of a. So if a is negative, which does exactly what you would think it would do, instead of going up we go down or down we go up, we don't ever talk about an amplitude as a negative value. We always say it's just the absolute value of a. So if the number in front of sine were a -3, we would still just say the amplitude is 3. The period, as we've been finding, is we take our 2 pi and we divide it by the number that's inside there. So if it was a 1/2, we're actually multiplying by 2, which gives us 4, a bigger number. And if the number in there is bigger than 1, then we're dividing by that, which makes the period smaller. Phase shift is c, and if c is positive, then we're shifting to the right, and if c is negative, we're shifting to the left because the minus sign is built in. So let's go ahead and graph. The first example, which is in the notes, is y equals 3 sine of 2 times x minus pi over 4. Okay. So we have a lot going on here. And before I create my scale, I'm going to just set up the information. So in this case, the amplitude is just 3. The phase shift is pi over 4 to the right. And this is how I want you to write your answer. You would say the number pi over 4 to the right or to the left. Our period is 2 pi over b, which b is 2 in this case. So the period is pi. Okay, so we have our amplitude, period, phase shift, and on the problem set, you're actually just going to answer questions, what's the amplitude, phase shift, period, and this is how I want you to answer that. So now we know that we're going to start at the phase shift, and we're going to go 1 period from there. And there's going to be 5 key values between the beginning and the end, including the beginning and the end, which means we're dividing that period into 4 equal parts. And so this is where the scale becomes important. So I want pi to be divided into 4 equal parts, which gives me pi over 4 as my scale. That's my first choice for my scale. And if I look at my phase shift, it is also pi over 4, and so the phase shift matches up with the scale perfectly. So that's the scale I'm going to go with. I'm going to go with pi over 4 for a scale. So I'm going to start pi over 4, pi over 2, 3 pi over 4, and then I have pi, which is 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and then 8 pi over 4, which is 2 pi. And we continue to fill out this whole x-axis. We want to make as much of this, we want to fill up this graph as much as we can with our trig function. All right, now I probably, since the period is only pi, I could have gotten away with making every other box pi over 8 and just stretch this out a little bit. It doesn't matter. Do what you're comfortable with. It might be fun to count in pi over 8s, fractions of 1/8 pi instead, just to get used to it. Whatever you want. But taking the period and dividing it into 4 equal parts is a great starting point for your scale. It's not always going to work, but it's a great starting point. And then vertically, I want to make sure that I'm going up to 3 and down to -3 because of my amplitude being 3. So normally sine would start at the origin, but it's shifted pi over 4 to the right, which is what this says here. So I'm actually going to start it right. Let's just use a different color so it stands out a little bit better. I'm going to start right there. And then this scale is also how far it is from one key value. This is also the distance from one key point to another. And so as long as I keep, it's great to use it as your scale because then it's easy to count. So every time I get to another box that I've labeled here, that's my scale, but it's also the distance from one key point to another. So I start at 0, but then I go up to the top point, pi over 4 away, and then back down to 0, and then -3, and then 0, and then 3, and then 0, and then -3. And that pattern continues forever. So I'm going to give the graph the respect of extending it to the edge of the graph paper, which is not forever. It's not forever, but I'll do my best here to make this graph pretty. Sine and cosine functions are actually very pleasing to the eye normally, and I just can't ever really graph it the way that I can't ever do it justice. All right, so there's that example, and notice how it still looks just like the other graphs that I had, because I picked the scale and in the x and the y direction so that this would fill up as much space as possible. Okay, so then the last example we have is a cosine function. So y is equal to cosine of 2x plus pi plus 3. And I think for the purposes of this, let's just ignore the plus 3. The plus 3 does exactly what you would think it does. Instead of the x-axis being the center of my wave, y equals 3 would be the center of my wave. However, I'm never going to ask you to graph something like that. And if I do, you can call me a liar and I'll just give you the points, okay? So let's instead just focus on cosine of 2x plus pi. What we have to do first is we have to make sure that this 2 is factored out. So this is actually 2 times x plus pi over 2. And if I didn't factor out that 2, I would think the phase shift is pi to the left when it's actually pi over 2 to the left. Okay, so when we talk about amplitude, that's just 1. My period is 2 pi over b, which is 2. And so pi, again, is my period. And then my phase shift is pi over 2 to the left. And since my period is pi and we want to find a good scale, the distance between my key points is going to be pi over 4. Since my phase shift is pi over 2, which is a multiple of pi over 4, 2 pi over 4 is pi over 2, and so pi over 4 sounds like a really good scale. Now, if I had a period of pi and I was using pi over 4, but my phase shift was pi over 3, that's when I would want to reevaluate, and I'd probably, the distance between my key points is still pi over 4, but I couldn't use pi over 4 as a scale. I'd have to use pi over 12, because pi over 4 and pi over 3, the least common denominator would be pi over 12. And so then I'd have to count up fractions of 1/12 pi. 2/12 pi is pi over 6. 3/12 pi is pi over 4. And then 4 pi over 12 is pi over 3. And so I'm getting both of these values using this scale. But for this problem, pi over 2 fits perfectly in with pi over 4, so I'm just going to use pi over 4 as my scale. Again, on the last one, I said I could have stretched it out a little bit. I could use pi over 8 every other one. It doesn't matter, just as long as you're comfortable with counting in fractions of pi. So pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Same thing in the negative direction. I'm going to stop talking and you can just listen to the pencil hit the iPad. The amplitude is 1 here, so I'm going to make this 1 and this -1 down here. And we're starting, let's use a different color here, we're starting, let's try yellow. We're starting pi over 2 to the left, so that's here. No, that's not going to work. There we go. Starting pi over 2 to the left. But this is cosine, and so cosine starts at 1. So we're starting pi over 2 to the left, we're up at 1, and then pi over 4 is the distance between all my key points, and which is also my scale, so then my next one would be 0, and then -1, and then 0, and then 1, and then 0, and then -1, and then 0, and then 1, 0, and -1. And working over to the left as well. And you're going to see that these two graphs, the one that I just did and the one that I'm about to do, are exactly the same graph when I look at them when I'm done actually drawing them in. They look exactly the same on the graph paper, but they're not the same graph because this one only goes up to 1. Horizontally, they actually are exactly the same, but the one above is stretched vertically by a factor of 3, where this one is not. The reason they look exactly the same is because I picked the scale so that it would fill up as much of the graph as possible, and that's the goal. These graphs are going to look the same. They're all going to look very similar. What I'm going to be focused on is, do you have the right scale in the horizontal and the vertical direction? Are you starting in the right place? So here is where we started. Is the period correct? Is the spacing correct? If you have the right scale, you're going to get most of the points for these graphing problems, given that you have something that looks like a sine or a cosine function graphed on there. So keep this all in mind. Try the problem set. Email me with any questions. And I'm sorry that we won't get to see each other again. And I will be posting more information on Blackboard when we get closer to our next exam, which probably had said April 9th, but it's probably going to be somewhere around there. But I will definitely give you the information.